Hello friends, welcome to EC Academy.
In this lecture, let us understand the problems on amplitude modulation. Using the message signal m of t is equal to 1 divided by 1 plus t square, determine and sketch the amplitude modulated wave for the following modulation index values. Mu is equal to 50% and mu is equal to 100%. So they have given different modulation index. For these modulation index, we need to determine and sketch the amplitude modulated wave for the given message signal. Now the message signal which is given is m of t is equal to 1 divided by 1 plus t square. Now let us find the value of m of t by taking different values of t. Let us take t is equal to infinity. For this, let us find m of t. So if we take t is equal to infinity, m of t value will be equal to 0. Likewise, if we take t is equal to minus 3, we will get m of t is equal to 0.1. If we put t is equal to minus 2, m of t will be equal to 0.2. If we t is equal to minus 1, m of t will be equal to 0.5. If we put t is equal to 0, m of t is equal to 1. If we put t is equal to 1, m of t is 0.5. If we put t is equal to 2, m of t is 0.2. If we put t is equal to 3, m of t is equal to 0.1. Likewise, if we put t is equal to infinity, m of t is equal to 0. So here, as you can observe, we are getting m of t as 1, which is maximum value here, and m of t is equal to 0, that is minimum value. That's why we can say m of t maximum is equal to 1 at t is equal to 0, and m of t minimum is equal to 0 at t is equal to infinity. So let us sketch the message signal by considering these two values. So if we consider time in x-axis, for t value infinity and minus infinity, the message signal will be having minimum value, and for t is equal to 0, message signal is having the maximum value. So maximum value is 1 and minimum values are 0. So we can draw the waveform. So this is the message signal where we are having maximum value at t is equal to 0 and minimum value at t is equal to minus infinity and plus infinity. So this is the message signal. Now let us take the first condition where mu is equal to 50%. So if we say mu is equal to 50%, which means we can take mu is equal to 0.5. We know the standard equation for modulated signal as s of t is equal to AC into 1 plus Ka m of t into cos 2 pi fct. Let us take this as equation number 1. We know mu is equal to Ka m of t maximum. So from this we can write Ka is equal to mu divided by m of t maximum. So if we substitute the values, we can write Ka is equal to mu is 0.5 divided by m of t maximum is 1. That's why we can write 1 here. So we'll get Ka is equal to 0.5. Therefore, in place of Ka, we can write 0.5, and in place of m of t, we can write 1 divided by 1 plus t square. Therefore, the AM modulated signal can be written as S of t is equal to AC into 1 plus 0.5 into 1 divided by 1 plus t square into cos 2 pi fct. So this is the amplitude modulated wave for mu is equal to 0.5. Now we need to sketch this waveform. So to sketch the waveform, let us take two terms, which is A maximum, that is equal to AC into 1 plus Ka m of t maximum. So m of t maximum is 1, Ka is 0.5. So 0.5 multiplied with 1 is 0.5. 1 plus 0.5 it is 1.5. Therefore, A maximum will be equal to 1.5 AC. Now let us find A minimum. A minimum can be given as AC into 1 plus Ka m of t minimum. M of t minimum value is 0. Ka is 0.5. 0 into 0.5, it will be 0. 1 plus 0 is 1. So the value of A minimum will be equal to AC. Now we need to sketch this waveform. So let us take t in x-axis, s of t in y-axis. Now we need to take the minimum value, which is equal to AC. A minimum is equal to AC and A maximum is 1.5 AC. So A maximum is equal to 1.5 AC. Similarly, in the negative half, it will be AC and 1.5 AC. So maximum value at t is equal to 0, minimum value at t is equal to infinity. So the waveform will be like this. So this is the AM modulated wave for mu is equal to 0.5. Now if we take the second case where modulation index is 100%, we can write mu is equal to 1. So this is the standard equation for AM modulated signal. So if we take the expression for Ka, we can write it as mu divided by m of t maximum. So mu is 1 divided by m of t maximum is also 1. Therefore, we can say Ka is equal to 1. Therefore, the expression for S of t can be written as AC into 1 plus the value of Ka is 1. 1 into m of t, we can write it as 1 divided by 1 plus t square into cos 2 pi fct. So this is the expression for AM modulated signal for mu is equal to 1 and Ka is equal to 1. Now to sketch this AM modulated signal, let us consider A maximum and A minimum formulas. So we know m of t maximum is 1, Ka is also 1. 1 into 1 it is 1, 1 plus 1 it is 2. Therefore A maximum will be 2 AC. If we consider m of t minimum as 0 and K as 1, so it will be 0 into 1 it is 0, 0 plus 1 it is 1, 1 into AC it will be AC. So we got minimum value A minimum is equal to AC and A maximum is equal to 2 times AC. Again, in the negative half we can take AC and 2AC. So the maximum value of waveform will be at t is equal to 0, minimum value at infinity. So we can write the waveforms like this. So we can write the carrier signal, which is AM modulated. So this is the sketch of amplitude modulated signal for modulation index as 1 and Ka is equal to 1. This is about problem on amplitude modulation. Hope you have understood the topic. Thank you.